Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, my friends. Welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do every Wednesday. We are here, and we just help you build your confidence and your competence in your math skills. Because, y'all, these math tests are not easy. They are hard. And so we are just here to help you build that confidence and that competence so that you can walk into that test ready to go and ready to kick that test. We do also offer boot camps for each of the exams. And so this is just a little taste of what you would get if you were to take one of our boot camps. All of that said, I love to tailor our sessions for your needs. And so I always have a running next week section. So last week, someone specifically asked for combinations, permutations, stuff like that. And so we will definitely be going over that today. But if you have things that you're like, man, I wish she would have gone over this, whatever that is, then that is helpful for us to know because I like to craft and build the problems based on the needs of the people that are watching it. In the comment box, let me know where you're from, what test are you prepping for, and the get to know you question will be, all I can think about is that our school had a water main break today, and I'm like, have you ever experienced a water main break? But that's kind of a silly get to know you question. So are you a coffee drinker or not? And if you are a coffee drinker, have you had foxtail coffee or not? I don't know how widespread foxtail coffee is. It used to just be this like little coffee shop here in Orlando. And it has absolutely exploded. Like there are so many foxtail locations now. And I actually really like it. I'm not really a coffee drinker. Like I don't have to have coffee every morning. But I do enjoy like the smell and the taste of coffee. But I'm like a more like a sugary coffee person than a coffee person, if that makes sense. Hello, Tara. General knowledge. I will say I'm biased because I did the course, but out of all of the courses, the GK is one of my absolute favorites because it is chock full of resources. So if you are not in the general knowledge boot camp that I do, you should totally go check it out. Just because it is chock full of resources, and you're not a coffee drinker and you don't have foxtail. That said, our foxtail, the one that we just got, you take it on the 15th. So close, like 10 days away. The foxtail that we just got also has a gelato station. And I'm a huge ice cream fan. And so that's been kind of fun because we can go up there and get ice cream. And my husband loves coffee. And so he loves the affogato, whatever it's called, which is like ice cream with a shot of espresso poured over it. It smelled so good. All right, let's go ahead and get started with the first problem. I'm going to flip to the first problem and run and get a tissue because my nose is running like crazy. Y'all, I think I have allergies. Like, I feel like I have been sick more this year than ever. I feel like I have either like had to cut math night short because of my voice, or like we don't have math night, or I just muscle through it. I'm like, oh, sorry guys, my nose is stuffy. I don't know what it is, but I guess it's part of living in Florida. You like hot fudge. I love hot fudge. Like, I am a huge hot fudge on top of ice cream fan. All right, let's go ahead. I'm going to scroll to the next problem, grab a tissue, and then we will read it together. Okay, problem number 1. How many numbers are there from 500 to 650 inclusive, which are neither divisible by 3 nor 7? How many numbers are there from 500 to 650 inclusive, which are neither divisible by 3 or 7? All right, so this is an interesting problem. Tara, I'll answer your question in 1 minute. So this is an interesting problem because there's quite a bit of information that it's asking. So how many numbers are there from 500 to 650 inclusive? Inclusive means we're including 500 and 650. And so I want you to think about this. If I said how many numbers inclusive are there between 2 and 4? If I subtract 4 minus 2, that equals 2. But if I list all the numbers that are between 2 and 4 inclusive, it would be 2, 3, and 4. Anytime we're working with inclusive, we have to add 1 to it because you're finding the difference, but then you need to include the number before it. And so inclusive means add 1. So how many numbers are there just in general from 500 to 650? Well, 650 minus 500 would be 150 plus 1. There are 151 total numbers between 500 and 650. So the first step after figuring that out is we have to figure out how many of those are divisible by 3. I know 500 is not divisible by 3. And even though this problem is a high school problem, knowing your divisibility rules is really something everybody should know. So if a number is divisible by 3, then the digits added up would be divisible by 3. So I know that 500 is not divisible by 3. because 5 plus 0 plus 0 equals 5, and 5 is not divisible by 3. But I know that 501 is divisible by 3 because 5 plus 0 plus 1 is 6, and 6 is divisible by 3. Well, what is that number? What is that factor that is the other factor to that? Well, 501 divided by 3 equals 167. 3 times 167. Now, I know 650 is not divisible by 3. So let's go 649. 9 plus 4 plus 6 is 19. That is not divisible by 3. 648, 6 plus 4 plus 8, 18 is divisible by 3. So 648 divided by 3 is 216. So you're like, okay, that's great and all, but what does that even give me? Well, they want the number of numbers that are not divisible by 3 or by 7. They want the numbers that are not divisible by 3 or by 7. So if we are looking for that, then I can subtract. If we are looking for that, I can subtract 216 minus 167 because that's going to give me the number of factors that are between these products. 216 minus 167 equals 49, but we're inclusive, so add 1 is 50. So there are 50 numbers between 500 and 650 divisible by 3. Now, I'm going to go through that same process for the number 7. So is 500 divisible by 7? Nope. Is 501 divisible by 7? Nope. Is 502? Nope. Is 503? Nope. Is 504? Yes. 504 is divisible by 7. 7 times 72. 650 divisible by 7. 649, 648, 647, 646, 645, 644. 644 is divisible by 7, and it is 92. And I'm just using my 4-function calculator to calculate all of this. And now I'm going to do 92 minus 72 plus 1, which is 21. So now I have 50 numbers that are divisible by 3. I have 21 numbers that are divisible by 7. But how many of them are divisible by both 3 and 7? How many of them are divisible by both 3 and 7, which would be 21, right? Because that means that they're going to overlap. So, same process. $504 equals 21 times 24. And 630 equals 21 times 30. So 30 minus 24, inclusive, plus 1 equals 7. So now what? Now I have to pull those 7 numbers out of my 50 and my 21. So I have 50 plus 21 equals 71 minus 7 equals 64. Now, I've solved this problem already once, but my original number was 87. So now I'm trying to figure out why I got because these are the numbers that are, I'm like, why am I like not getting the right answer? Here's why. Because this is the number of numbers that are divisible by 3 and 7. And so now I have to take my 151 and subtract the 64. And that's going to give me 87, which is the number of numbers that are not divisible by 3 or 7. I was like, I knew the answer was 87, but I was trying to figure out, like, why am I not getting it? Because this is the numbers that are divisible by 3 and 7. How do you sign up for the boot camp? You can go to our website, thelearningliaisons.com, and search for your test, and you'll be able to find it there. Hey, Tanya, it is good to see you. How much is it? It depends on what plan you choose. So you can choose a monthly plan where you have access to literally all of our boot camps, or you can buy just the GK boot camp for like a year-long access or lifetime access. So there's like a variety of like price structures that you can go with. It's just up to you how long you need it for and stuff like that. All right, questions about this problem? All right, let's go ahead and move on to problem number 2. And like I said, if you have anything that you want me to go over in the upcoming weeks, let me know in the next week section, and I will absolutely include that for you. Sarah solved this problem below. Where did Sarah make her error? Step 1, step 2, step 3, step 4, Sarah didn't make an error. Where did Sarah make her error? All right. So this is definitely for my like K6 elementary people, pre-K through 3. However, I mean, it really could be for anybody because error analysis is a super popular thing on these exams, especially if you're taking a non-content based exam and you're taking a teaching exam. This is definitely one of the strands or the standards that they assess you on. And so what I like to do, honestly, is I like to write down the problem and then I like to solve it myself because sometimes it's hard to see the error. Now, in a simpler problem like this, you might be able to find the error just by looking at the problem. But if you're having a hard time finding the error, like if you're doing an error analysis problem and you're having a hard time finding the error, I highly, highly, highly encourage you to look at the first step, cover everything up, pull it over here, and then solve it on your own, and then look for the error. I'm going to go ahead and do it both ways. So, step number 2, they took the original problem from here, and then they did something with it. So, it looks like they multiplied the 8 and the negative 9 through the parentheses. 8 times x is 8x. 8 times 3y is positive 24y. 9 times 2x is negative 18x. And negative 9 times positive y is negative 9y. There's the error right there. So she made her error in step 2. Again, if you're not sure of the error or you're having a hard time finding it, absolutely go ahead and rewrite the problem and then solve it on your own. Now, we're humans, and so it's a possibility that we could make an error ourselves, but it's at least a good first step to be able to see and compare, oh, my answer definitely did not match her step 2, so let me confirm and look into that. So that's really where when we're looking at error analysis, it's helpful to be able to solve the problem on our own. All right, let's look at problem 3, which is similar to problem 2. Which of the following properties was used to simplify the following expression in step 2? Which of the following properties was used to simplify the following expression in step 2? So really all we need to do is look at step 2 and figure out, what did they do? Did they do the distributive property, the closure property, the commutative property, or the identity property? So in this situation, when we see parentheses and then the parentheses disappear, usually that means that we've used the distributive property. And in this case, we did. We distributed the 8 all the way through. We distributed the -9 all the way through. So that is the distributive property. The commutative property says that when I do addition or subtraction in any order, then it results in the same answer. So 3 plus 5 is the same thing as 5 plus 3. This is definitely not the commutative property. The identity property says that of addition and multiplication says that if I do some addition of something or multiplication of something to a number and it ends up equaling that same number, then that's the identity property because it's staying as its own identity. So if the number 4 is 4 plus 0, that is the identity property because 4 plus 0 equals 4. So when I add 0 to a number, that is the identity property of addition. When I multiply a number by 1, that is the identity property of multiplication because what I'm multiplying by 1, I result in the original number. So that is the identity property. The closure property states that performing an operation on any 2 numbers in a set results in a number that is also in that set, but we're not dealing with a set here. So in this case, we're not dealing with the closure property. So it's wrong because it needed to be a -9. Absolutely, Tara. That was a good question. In this problem, step 2 was wrong because I needed to do -9 times y, which results in a -9y. And a positive and a -9 are extremely different values. And so that's why it is wrong. Good question. Yeah, I love when you ask questions because it just makes it a little bit more interactive and it helps you understand the content a little bit better. All right, let's go ahead and look at problem number 4. Which of the following is equivalent to number 275? Which of the following is equivalent to the number 275? All right, this is another one for my elementary people because this is what we like to call, representing numbers in a variety of ways, right? So we are representing this number 275 in a variety of ways. So I can do expanded form. Expanded form. So if I write the number 275 here, whoops. All right, let's reshare this screen. Just disconnected, no big deal. There we go. Present, share screen. All right. So which of the following is equivalent to the number 275? So if I write the number 275 right here, I can represent it in a variety of ways, right? Like I could represent it as expanded form. I could represent it in place value form. I could draw a picture of it. I could write it in like words. There's a variety of ways I can represent it. So expanded form says I'm going to stretch that number out. So 200 plus 70 plus 5. I take the value of that number, which is 200. That is not a value of 2, and I expand it. I can draw a picture. 100, 200, 10, 20, 30, 40, 50, 60, 70, 1, 2, 3, 4, 5, right? I could do place value form. 200s, 7 10s, 5 1s. But when I look at my answer choices, none of my answer choices represent that. So how in the world am I going to solve this? Well, they are showing us the number represented differently. I know it's not 2 plus 7 plus 5 because it's 200 plus 7D plus 5. I also know it's not 200 plus 7 plus 5 because we're missing the 0 here. So it has to be B or D. 300 minus 35. That would be 265. And you're thinking to yourself, how in the world is it 27 10s and 5 1s? Well, how many 10s are in a 100 block? Like if we think about truly how many 10s there are, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. There are 10 10s in 100. So this is 10 10s. This is 10 10s. So 10, 20, 21, 22, 23, 24, 25, 26, 27 10s and 5 1s, which is B. Questions? Hi, Natalie. Measurement and geometry. Probability. Discrete math. What exam are you specifically studying for so that I can, because measurement at the K6 level looks very different than measurement at the 7th grade through 12th grade level. So what specifically are you looking for, Natalie? Math 4 through 8, that's helpful. And math 4 through 8 is actually exactly the range pretty much of the GK. So Tara, anything I do with that is going to directly impact and help you because the GK really spans from about 4th to 8th or 9th grade. But I will add GK math on here. Hello, Marcos. It's good to see you. You're late, but you're here. Listen, it's okay that you're late. We're happy that you made it. So join the math party. Here we go. All right, let's go ahead and solve the next problem. And actually, my computer is about to die. So I'm going to let you read this problem and I will be right back. I'm going to even put be right back. I'm going to go get my computer charger and I will be right back. All right, I'm back. We're going to read this problem together. Just didn't want the computer to die on us. A pool technician is filling up a pool and monitoring how many gallons of water are in a swimming pool over a period of time. The technician recorded the gallons in the pool on each hour as shown below. Which of the following equations relates the hours past H and the number of gallons in the pool G? Which of the following equations relates the hours past H and the number of gallons in the pool G? All right. So this is an interesting question. This is definitely a problem that really elements of it could be for anybody, right? So when we look at this problem, we have to think about what does each equation say. So this equation right here says the hours is going to equal 500 times the gallons plus 100. If I have only had 2 hours pass, can this equation make any sense at all? No. Like, I'm not going to multiply the number of gallons in the pool by 500 and add 100 and have it equal 2. It just doesn't make sense. Okay? So that is definitely out. Multiply 550 times the number of hours, and it could equal G. In fact, I'm noticing that everything is equaling G at this point, and that makes sense. If I multiply these numbers by something, it could equal a high number of gallons. Now, here's what I would do if you don't understand linear equations, you don't understand slope, you don't understand y-intercept, use your answer choices to help you. Use your answer choices to help you. Plug in a random hour into each of these equations and see if it spits out the right answer. So I don't ever like to pick the first one because sometimes they will create multiple equations that equal the first one, but then they won't equal the rest of them. So I always like to pick something in the middle. I'm going to pick 5. So 550 times 5 should equal 2,750. 500 times 5 plus 100 should equal 2,750. 2 times 5 plus 1,100 should equal 2,750. That's how I'm going to figure out which equation is right. Hey, Leah, it's good to see you, my friend. I always love seeing your smiling face in here. It makes me so happy. So thanks for coming. Thanks for joining us. All right, 550 times 5. That indeed equals 2,750. 500 times 5 plus 100. That equals 2,600, so it can't be C. 2 times 5 is 10, plus 1,100 is 1,110. So my answer has to be B. Plain and simple. All right, let's look at this exact same problem through a totally different lens. Let's look at this exact same problem through a totally different lens. So a pool technician is still filling up his pool, and he's still monitoring it to see how many gallons of water are in that swimming pool over a certain period of time. The technician recorded the gallons in the pool on each hour as shown below. Here's where we start to change a little bit. If the pool the technician is filling up is 10,000 gallons, After how many hours will the pool be completely full? After how many hours will the pool be completely full? So this is an interesting problem, y'all. This is an interesting problem because we are no longer figuring out the equation or anything like that. We're trying to figure out after how many hours. So I'm looking for a pattern. So as each hour increases, how much is my water in my pool increasing? Plus 550. Plus 550. Plus 550. Plus 550. So if I do 6 times 550, it equals the answer that I'm looking for. Now, if you didn't notice this part, but you noticed this part, you could absolutely sit here and do 3,300 plus 550 plus 550 plus 550, and you could keep tally of how many hours that is. You could also do 10,000 divided by 550. Why? Because if I go backwards and I subtract 550, after 1 hour, I would have 550 gallons. And at time 0, I would have 0 gallons. If I continue with my pattern of 550, 550, 550, 550, 550, I would have 0 gallons in my pool. And so if I just multiply by 550 or do 10,000 divided by 550, I can figure out how many hours it would take. And this would equal 18.181 hours. So what would your answer be? Would it be 18 or would it be 19? This is kind of a trick question. Here's why. Because normally when we round, if I have 18.181 and I'm rounding to the nearest hour, when I look next door, that 1 tells me to absolutely round down. Like, hello, it's only 18.1. Like, that's not even close to 19. However, if I stop at 18 hours, is my pool going to be full? If I stop at 18 hours, is my pool going to be completely full? No. So I have to fill up my pool for 18.18 hours. And after that 19th hour, at that 19th hour, my pool will be completely full. These kinds of problems are interesting because you have to be super duper careful to make sure that you're not rounding in the wrong direction, because 90% of the time when we round up if it's 5 or above and down if it's below 5. However, we can't use rounding rules in all real world situations, because in situations like this, we need that extra time for it to be completely full. So it's important that you pay attention to that. All right, let's go ahead and move on to the next problem. This one we kind of answered in the previous problem, so I'm not going to spend a whole lot of time on it. This one just says the same thing. A pool technician is filling up a pool. The technician recorded the gallons in the pool. After 1 hour, how many gallons were in the pool? Well, after we figured out that we were adding 550 each time here, we can subtract 550 to get the 1. And so you would have 550 in the pool. That one was not, we've already kind of discussed all of that, so I'm not going to spend a whole lot of time on that. Which of the following scenarios would you use permutations to solve? Which of the following scenarios would you use permutations to solve. A group of 9 people wants to form a committee of 3 people. How many different committees can be formed? There are 3 items in a kid's combo meal. A sandwich, fries, and juice are all placed in the kids' meal box. A student is organizing their bookshelf and is only keeping 4 of the 6 books they read this year. In how many different ways can the books be placed on the shelf? A farm needs to purchase 4 cows for their homestead. There are 9 cows available on auction day. How many groups of 4 cows can be purchased? All right, so which one would I use permutations to solve? Which one would I use permutations to solve? So the difference between permutations and combinations, a permutation refers to an arrangement Whoopsies, it just disconnected again. 3rd time's the charm. We'll just reconnect it. No big deal. Sometimes that happens. All right. So a permutation is one in which order matters. Order matters. Order matters. Whereas a combination is a selection of objects where the order does not matter. So a group of 9 people wants to form a committee of 3 people. How many different committees can be formed? It doesn't matter. Like, so if my people are A, B, C, D, E, F, G, H, and I can do A, B, C, but I don't need to do C, B, A also, right? Like, it doesn't matter if it's A, B, C, or C, B, A, or B, A, C. As long as those 3 people are in a group, that is one committee. It doesn't matter what order they're in. And so that would not be a permutation. That would be a combination. And that's what I want you to think about. Permutation is going to have more possibilities than combination, because with a combination, none of these matter. So I don't need to come up with all of those ways. I only need to know that A, B, and C are in a group. There are 3 items in a kid's combo meal. A sandwich, fries, and a juice are placed in the box. Does it matter what order they are placed in the box in? Does it matter if I put the fries in first and then the sandwich, or the juice and then the sandwich? No. So that is not a permutation either. A student is organizing their bookshelf and is only keeping 4 of the 6 books they read this year. In how many different ways can the books be placed on the shelf? So if they are only keeping 4 books, but they want to know how many different ways those books can be placed on the shelf, I could put book A, B, C, D, if those are the 4 books I'm keeping, but then I could also do B, A, C, D, but then I could also do A, B, D, C, but then I could also do B, A, D, C, right? So there's a lot of different ways that I could do just A, B, C, and D, but then I could also do B, C, D, and E. And so this one is where order matters. A farm needs to purchase 4 cows and there's 9 cows available. How many groups of 4 cows? This is the same exact situation as A was. It doesn't matter what order those cows are purchased in. There's not a first, second, or third place. So there's no reason for me to think that that would be a permutation. It's definitely a combination. And this was, I should have put a little star next to it. This was a specifically requested concept from somebody. And I love when we get to do this kind of stuff, because it allows me to serve you and serve the needs that you have. Let's go ahead and look at problem number 7. A brand new honor society is being formed with 12 members. A president, a vice president, a treasurer, and a secretary need to be selected. How many ways can selecting a president, vice president, secretary, and treasurer occur? So there's this fancy permutation formula that I can rattle off to you. So your combination formula is n factorial divided by r factorial times n minus r factorial. And your permutation formula is n factorial divided by n minus r factorial, where n is the number of items that you have, and r is like how many of those items you're using. So in this case, I am looking for a permutation because I'm looking for order matters. It matters what happens after my president and then vice president and then treasurer and secretary. So I have 12 factorial because I have 12 members divided by 12 minus 4 because I have 4 positions. Wow, I really don't know what is going on with my iPad today. It just doesn't want to stay connected. Sometimes it struggles to actually connect. So I'm glad it's not struggling to actually connect. It just doesn't want to stay connected tonight. All right. Close factorial. Now, if I look at what this actually means, I have 12 factorial divided by, so if I actually do that out, 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 12 minus 4 is 8. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All of this cancels out because anything divided by itself is 1. So I'm just left with 12 times 11 times 10 times 9. So when I do that in the calculator, it equals 11,880, which is the correct answer. Now, if you can't remember the permutation or the combination formula, what I want you to recognize is that I have 12 possibilities for the president, right? But then once the president is chosen, that person cannot serve as vice president also. So now I have 11 people to choose from. And once that person is chosen, I only have 10 possibilities for treasurer and then 9 possibilities for secretary. And so that's kind of how I like to think about it sometimes. It's not always like the fail-proof way of doing it, but that's kind of like how I like to think about it, because sometimes memorizing formulas is just hard. And so that's how I like to think about it sometimes. All right, we have time for maybe one more problem, and then I will turn it back over to Dr. A. Be thinking about what you want to see me go over in the upcoming weeks, and I will be happy to add it in the upcoming weeks. Be thinking about what you want to see, and I'll be happy to add it. All right. Problem number 8. Simplify the following problem. 34 minus 10 divided by 2 minus 6 times 4 plus 2 to the third power. All right. So this is a classic PEMDAS problem. Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally, which says parentheses, exponents, multiplication, division, addition, subtraction. But multiplication and division are together. They're a partnership. and addition and subtraction are married. They're a partnership. So what that means is after I do my please excuse, and I get to my multiplication and division, I'm going to do it from left to right. So that means if division comes first, I'm going to do that first. Then once I do my multiplication and division, then I'm going to move from left to right for my addition and subtraction. So 34 minus 10 is parentheses, so I'm going to do that first. 34 minus 10 is 24. Divided by 2 minus 6 times 4 plus 2 cubed. You'll notice that I am going to write every single step below. 2 cubed, 2 times 2 times 2 is 8. Exponents taken care of. I am not going to do more than one thing in one step. Parentheses and exponents are done. Now I'm going to do multiplication and division, but I am going to do them in the order that I see them. So I'm going to do 24 divided by 2, which is 12. Keep everything else the same. Now I'm going to do my multiplication. Negative 6 times 4 is negative 24. Done. Now I'm going to do 12 minus 24 because the subtraction comes first. Negative 12 plus 8 equals negative 4. B is the correct answer. Questions about that problem? All right. Let me know in the comment box what you want to see me go over in the upcoming weeks. I look forward to seeing you all next week for Math Wednesday. I have my running list going, but if you think of anything else, let me know. I hope that you have a great rest of your week, and I'm going to turn it back over to Dr. A.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.